In this session, we discuss the phasor diagram analysis for the AC flowing through an inductor. So to draw the phasor diagram for AC flowing through an inductor, we have to first consider how the voltage and currents are in the circuit. We understood that the voltage V equal to Vm sin omega t is applied across the inductor. Then the instantaneous current through the inductor will be Im sin omega t minus pi by 2. This is what we have seen. Okay. So this has to be represented by the phasor diagram. And for that, let us consider the waveform first. So when I draw the waveform, for this, I will be getting the wave like this guy. This is omega t, and this is initial value. Let us take that Vm this much, and from this side Vm this much, and let this be pi by 2, and this is 2 pi by 2, and this is 3 pi by 2, and this is 4 pi by 2, and the voltage variation will be like this. Like this it goes. And this is nothing but V equal to Vm sin omega t. Now, to draw the waveform for the instantaneous current, let us assume the peak value is this much, Im. This is Im. This is Vm. And when you take omega t 0 at this particular point, then voltage will be 0. But when I say omega t 0 over here, what happens is omega t 0 minus pi by 2 will come. That means Im sin minus pi by 2 will become. And therefore, you can see that Im sin minus pi by 2 is minus of Im sin pi by 2. That means sin pi by 2 is 1, so it is I equal to minus Im. That means it will be here. So when the voltage is 0, current will be here. One more point. When omega t equal to pi by 2, that is voltage is maximum, let us see. Pi by 2 minus pi by 2 will come, so I equal to 0. That means when the voltage is maximum, the current will be 0. So the waveform for current will be like this. And when it is pi, it is found to be the maximum. Okay? And when it is 3 pi by 2, it is found to be 0. And when it is 2 pi, the value is again found to be maximum on the other side. And will be like this. Understood? So this is what you call Im sin omega t minus pi by 2. So you got the waveform for what you call instantaneous voltage and instantaneous current. Now compared to this, we have to discuss what you call the phasor diagram. So to draw the phasor diagram, I am taking the reference here as 4 quadrants. Let us assume 4 quadrants I have taken. And to draw that diagram, let me take the position omega t somewhere between 0 and pi by 2. So when it is between 0 and pi by 2, your quadrant will be the first quadrant. This is 0, this is pi by 2, and this is 2 pi by 2, and this is 3 pi by 2, like that it is going to be. So when I take the position here somewhere in between, the voltage when omega t equal to this much will be here. This is the voltage at that instant. So instantaneous voltage is this much at that point, so let me draw that over here. So this is the value of V at that instant. So what is this V? Let us see. For that, this V is actually the projection of that Vm. So what is Vm? This is Vm. So I take that Vm and keep that Vm over here, and I can see that this is Vm. So this is Vm, and therefore this will be your Vm sine omega t, because this is taken to be omega t. So projection of this Vm comes over here, and you get the value of Vm sine omega t. So you got the phasor of voltage here now. Now to get the instantaneous current at that point. So current will be downward here. So this is the position of current at that instant, and this comes 180 degrees below here, right? See this? It is going below. Okay? So as it goes below, and this is the value of I coming, and for that you measure the value of I, M, keep it over here and rotate it, and you can see it is coming to this particular point. See this? Okay. So this is Im, and therefore this is Im sine omega t minus pi by 2. It's because angle is taken from 0 to 90, like that it is going. So here I am taking it in the opposite direction. This is coming like this, and this is pi by 2, and therefore this angle omega t minus pi by 2 in the opposite direction. Okay. So minus of pi by 2 minus omega t, that is what you are getting, omega t minus pi by 2. So you can see that the angle between that peak value of current and voltage is always at 90 degree out of phase. Current is lagging behind the voltage by pi by 2. So as the voltage goes like this to the second, then the current will come to the first quadrant like that. As it rotates, means as the voltage wave completes one sine wave here, the current also goes on one full wave, but pi by 2 angular difference there. So this is what the phasor diagram for, what do you call, inductor, AC through an inductor. Very important for when we analyze the combination of what you call the elements like current and inductor together, like that. When it goes like that, this individual phasor diagram must be there in your mind. Then only you can apply the conditions.